Okay, hi, I'm Maciej Pytel, and I'm a software engineer at Google. I'm working on autoscaling in Kubernetes, which is what I'm going to talk to you about today. Just before we start, how many of you have actually used Kubernetes or have any experience with Kubernetes? Okay, so most of you, but not all. I'll try to explain some basic concepts we'll be using. But this is mainly a very quick demo of just autoscaling features in Kubernetes. We'll not go into much detail. Okay, so let's start with thinking a bit about what the autoscaling is in general. I have a definition here saying that autoscaling is the ability of a system to automatically adjust the amount of used computational resources based on the load, which basically means that we want to be able to automatically provide our system with a reasonable amount of resources, such as CPU and memory. And by reasonable, I mean an amount that will allow it to run as we expect, but is not too wasteful. Also, we generally expect the requirements, the resource requirements of the system to change over time. So we want to be able to keep adding or removing the resources as required. And it's actually a pretty hard problem, so why do we want to put all the effort into doing autoscaling? The first thing that comes to my mind is traffic spikes. Basically, many applications can receive unexpected load at any point, and we need to handle it. We definitely don't want our server to just go out of memory because more clients decided to use our service. And autoscaling can help us with that. It can detect the spike. It can automatically add the resources. And I mean, another way I often dealt with this problem in my past projects was just giving my system so many resources that it will just never run out, just be safe. You know, that's a very, I think, natural tendency for developers. But it's not really cost effective. So autoscaling can just help us save money in such cases. And finally, I would say it makes our maintenance easier. I mean, many production deployments are, I don't know, thousands of containers running on hundreds of servers. It's just so difficult to maintain anyway that anything that we can automate just makes our life so much easier. Okay, I mean, hopefully you are convinced that you want to autoscale something. So how can we do that? And there are two basic ways of scaling our system. The first one is horizontal scaling. So we just adjust the load on our application by adding more or removing some instances of it. And yeah, just like that. And another approach is vertical scaling. And in this case, instead of adding or removing instances, we just make our existing instances bigger, and that should solve the problem. So those are some basic concepts, like basic autoscaling concepts. The question is, how can we apply them in Kubernetes? And before we start on that, let me give you a quick intro on the few basic Kubernetes concepts that I will use in this talk. Since not all of you have raised their hands. Okay, so I'm not going to go into detail, just very basic concepts. Pod is the basic unit of computation on Kubernetes. It's just one or more containers running usually a single instance of your application. I think it's okay to think of it about a pod as just a single instance of your application, like an Nginx server or something. It's very often a single container, so I think it's also okay to think about it as a container, but it can be multiple containers sharing some configuration and storage. As an example, we could maybe add some side container to our Nginx that provides some monitoring capability, and just make this a single pod, a single, basically, unit of our deployment. And that's it, really. Another concept is deployment. So this is a Kubernetes object that maintains a homogeneous set of pods of a given size. We provide it with a pod specification, and the desired number of replicas, and it just makes it happen. We can later change the number of replicas, and it will spin up new pods or just kill some pods we don't need anymore. It can also do other stuff like maybe rolling updates, but this is sort of not in the scope of this presentation, so I'm not going to go there. And finally, a node is just a machine we use to run our containers. It can be a VM, a bare metal. It's just a machine in our Kubernetes cluster. And those are actually all the non-autoscaling related concepts that we'll use, so hopefully not too complex. OK, how can we do the autoscaling in Kubernetes now that we have some concept of what we want to autoscale? As I had said, we have pods, which is instances of our application. And we may want to autoscale those. So basically just provide more resources from our cluster to a given application based on the load. And we can also autoscale nodes, meaning just add more VMs or bigger VMs as required to run all our pods, or remove them if they have low utilization to save some money. So currently in Kubernetes, we have a horizontal node and pod autoscaler. And we have started working on a vertical pod autoscaler, which we are hoping to release an alpha later this year. OK, let's dive into some details. We'll start with horizontal pod autoscaler, or HPA, as we call it. So an HPA is a Kubernetes object that basically manages the size of a given deployment. It monitors the load on every pod inside the deployment, and it automatically scales our deployment up or down based on what it observes. We set a target utilization for all our pods. For example, we can say, we want our pods to run at 60% CPU. That sounds like a reasonable usage, maybe safe-ish. And we can also provide it with minimum and maximum, just to feel safe that it's not going to suddenly spawn too many instances that we don't really want, or just have too little. OK, so that's the basic idea. So how does that actually work? It's pretty simple. Let's try to revisit our early example. So imagine we have a deployment, an Nginx deployment, and we have some users using it. It currently just have a single pod that is serving our users. And we have an HPA monitoring it. So when new users come and load increases, the HPA will basically notice that and will react by adding more pods. And then the traffic will be split among all those pods, and hopefully our deployment will be healthy and will use as much resources per pod as we want. So that's just as simple as that. And the exact algorithm it uses, I think, is equally simple. So to find out the desired number of instances of our application, all that HPA really does is it sums the utilization over all the pods. So say one pod have 50% CPU utilization, and then the other one will have 70. So the total is 120, and then it divides that by target utilization. Say if it was 60%, then we actually have 2 pods, which is the perfect value. Of course, it also respects our minimum and maximum that we have set. By utilization, by default, we mean CPU usage in here. We also have an alpha support for custom metrics, so that can be just any metric you provide, really, anything you want. But that being said, not all metrics work very well with this algorithm. We really expect our metrics to quickly react to the changing number of instances for this formula to work. So CPU usage is a pretty decent metric, because adding more instances that will take some load from the existing ones should basically make the existing ones use less CPU fairly quickly. Another good metric would be queries per second. We just add more instances, less queries gets to every single instance. That works pretty well. On the other hand, things like memory utilization would probably be a pretty bad match in this case, because most servers or applications really just don't give memory back just because the load has decreased. I mean, Java or Python server will just keep the memory it once obtained pretty much forever, right? So that is less perfect. Okay, after this short theoretical introduction, let's try to do that in practice. First of all, how big do I need to make it so you can read it? Is that big enough? One more. Okay? One more. I'm not sure how much more I can go before it stops fitting my screen. Okay, let's leave it there. So I'm going to do this demo on GKE, which is Google's hosted Kubernetes offering. All of these components, all of the autoscaling components of Kubernetes are actually open source, so they should work on any major cloud provider like AWS or Google Cloud Platform or Azure. And probably most self-hosted clusters as well. I'm just using GKE because of how easy it is to set up the cluster and just run this demo. Okay, because it takes about 5 minutes to spin up new cluster, I have already done it before. I couldn't think of anything entertaining to say why it was going on. So I'll just continue from that point. And this is a fresh cluster. I haven't really done anything with it. Actually, maybe we can start by just checking out what do we have. So the internet could be better, but I think it's decent enough. Okay, we just have basically 3 nodes, so 3 VMs in our cluster, and that's all. Nothing is running here. If I list all the pods, yeah, we don't really have anything other than some system stuff. Okay, so let's try to run something. Actually, first let me get some credentials and do this boring stuff. Let's try to run something now. So for this demo, I will just run a basically container with Apache server running some PHP code. It does some CPU-intensive computation on every request, so we can quickly ramp up our CPU usage with just a few simple requests. And that's basically how easy it is to run such a thing on Kubernetes. It should already be starting. Let's check our deployment. So we have a deployment running this PHP Apache server. Currently, the desired number of replicas is 1, and there should be a single replica, which is just fine. Let's see. Yeah, it's already running. So let's go here. Actually, sorry, misclick. And let's try to hit our service. I've just created a simple pod on our cluster running shell, just so I can execute some commands inside cluster. Kubernetes provides internal DNS, so I can just reach the service. So I should make this bigger, right? I can just reach our PHP service like that. And yeah, we got a response. It's OK. It's working. So let's try to do something slightly more interesting and more autoscaling. So I will create an HPA for this deployment. Once again, it's pretty simple. In using Kubernetes command line tool, the kubectl, you just kubectl autoscale your deployment. We provide our target CPU, in this case 50%, and we want between 1 and 10 pods running our PHP service. And that's basically it. We can now get our HPA. It takes a while to initialize, about 30 seconds, so it doesn't know our current usage yet. But it's getting there. Sorry. OK, so it already got there, actually. Currently, our utilization is 0, which is fair enough. We're not actually hitting the service at all. And we have a single replica. So let's try to get it to do some autoscaling. I'm just going to do the exact same thing. except I will do it in a loop. Okay, so it's just hitting the server continuously. And that will overload our single pod pretty quickly. So I would expect this to start getting slower in about 30 seconds or so as the load ramps up. And our HPA will notice that. It generally takes it about 30 to 50 seconds. That is configurable, but that's just how often our default monitoring solution scrapes the metrics. So we cannot get much faster than that without changing some config there. So let's try to see if it already figured out that the load has increased. So for now, it just noticed 40%, which is still below our target of 50%. So we need to wait for another update. But it will soon notice. So just to make the wait slightly more interesting, what will happen is it will figure it out that it needs more replicas. I would expect this to reach about 170, 180% CPU usage. Yeah, just right there. And soon it should get the replicas to 4, which is basically 186 divided by 50. And then we should be able to see that on our deployment. Yeah, it's already scaled up. So basically what happened is our HPA have figured out the load have indeed increased. It have scaled up our application. We should be good to go. Except there is, of course, one problem, because that would be a pretty quick talk if there wasn't. Our pods have been created, but they haven't actually been scheduled. And the reason for that is I have created a very small cluster, and there is no more machines for the pods to fit. So enter cluster autoscaler. I'm going to activate it. This is actually Google Cloud command that just deploys cluster autoscaler. It may look different on different cloud providers, but you can get it working. And that takes a few seconds, so we can go back to slides. So the idea of cluster autoscaling is keeping the size of our cluster reasonable. One of the primary use cases of Kubernetes is running on public cloud. So we can basically pretty easily add or remove VMs as we want. And they cost a bunch of money, so it's good to keep the number as low as we can without impacting our application. So let's imagine a simple scenario. We just have 2 nodes. This is actually pretty similar to what we have now in the demo. We have another one pod. It's not going to schedule just because there is no place. So cluster autoscaler will notice that, and it will just add a new node so the pod can schedule. And that's all fine, but imagine some time have passed and some of our pods stopped running. So now, I mean, every node is running something, but it's not perfect. I mean, the node C has like 25% utilization and node A have 50% utilization. We could improve that. And cluster autoscaler will actually do it. It will just move the pod from node C to node A in this case, and remove node C to save some money. A lot of this behavior is configurable, so like the usage thresholds and so on that will trigger it are configurable. And in general, what cluster autoscaler does is it scales up our whole cluster whenever a pod is pending, whenever it cannot schedule, basically. And that is happening as quickly as we can. The cluster autoscaler generally reacts within about 10 seconds. Of course, that doesn't take into account how long it takes the cloud provider to spin up a VM, which is sort of outside of our control. Scaling down is much slower just because we want to be safe. So by default, we'll just wait about 10 minutes to confirm that the machine is actually not needed and it's not just a fluke before we delete it. And this is much more complex than what HPA does, because in Kubernetes we have a lot of advanced scheduling features like pod anti-affinity or pod anti-affinity, which means some pods can only run on nodes that have some other pods or that don't have some other pods. or node selectors, which just picks some node. So we cannot just do it by calculating like CPU, memory, maybe GPU or other resources. We actually simulate the whole cluster inside of cluster autoscaler, and we run a lot of scheduler code to simulate if the scheduler would be able to schedule all pods. So we will actually run the scheduler code to confirm that it can schedule all the pods before we delete anything. Okay, hopefully by now we have managed to deploy cluster autoscaler, and yeah, it looks like that have been successful. So let's see what's going on, if there are any new nodes. And there probably aren't, yes, because as I said, it takes about 2 minutes to spin up a VM, start operating system and all this stuff, and we haven't just given it enough time. But the decision should have been already made, and cluster autoscaler reports what it does to us in various ways. I think actually the machine just have started because container is creating. But we can also look at the pod, and we can find the cluster autoscaler created event that says, yes, this pod have indeed triggered a scale-up of this specific kind of machines, and this is like the sizes of machines. And I think we actually already got our nodes. No, not yet. So this is basically all I wanted to show. In probably a minute or two, the nodes will show up, and then we can observe all our pods running. But in the meantime, I can take some questions if you have any. Sorry, can you? Sure. So basically, there is a master metrics API. So that's an interface in Kubernetes. And what you need to do is you need to provide some implementation of it. Currently in open source, I believe there is a Prometheus-based implementation. So you just need basically a Prometheus endpoint for your application, for whatever the source of your custom metrics is. And you just need to make sure it's just deploy a pod that is running this API, which should be available in the open source as of 1.7 release probably, which is next week. Okay, so we have our nodes, and we have all our pods running. So just one more comment is it's pretty, like the HPA and the cluster autoscaler are designed to work together for use cases like that, basically. HPA will create new pods regardless if they can fit or not, and cluster autoscaler will make sure they fit. And if HPA actually kills some pod because the load have reduced, the cluster autoscaler will more slowly remove all of those nodes to save us some money. So that's it. Any more questions?
The node scaling, that's not part of the Kubernetes, that's a Google Cloud thing.
So it's not part of the Kubernetes in the sense that it's not living in the main Kubernetes repository, but it's actually open source. It's running, it's in Kubernetes Autoscaler repository, and it's run as a pod inside your cluster. I used a gcloud command to activate it just because it's very easy to do it that way. But you can use it, for example, on AWS. I think they use it by creating a deployment with a single pod with cluster autoscaler. So it's a fully open source component. It supports Google Cloud, AWS, and Azure. And it has some interface that can be easily implemented. I think we have someone who is going to implement it for DigitalOcean soon, hopefully. Yes? Well, I mean, that is up to a user, right? But there are certain things that are more difficult, like not every application is equally simple to scale horizontally. I mean, if you have something running in just master backup mode, or just you can have a single something running, then you cannot probably scale it horizontally. It will adjust, yeah, the requests of a pod and the limits, yes. If the pod doesn't fit a node, it will spin up a new instance that can help this pod. It will, because it's running all the simulations, it will only spin instances that can help pod. If you actually define a pod that cannot be helped, I mean, that's possible, right? You can always request, I don't know, 600 gigabytes of RAM and just not have such a VM template. Then it will put an event on the pod saying not triggered scale up and some explanation why it thinks it cannot fit anywhere. Any other questions? Yes.
Possible to implement some like custom strategy how to scale?
Yes. Yeah. You mean for HPA or cluster autoscaler? I mean, I think for HPA algorithm is so simple that custom metric, I think, sort of constitutes strategy in this context. Like, it just calculates basically the average usage, so I don't see much place for strategy. For cluster autoscaler, you can. We have a expander interface, which basically just chooses a strategy. It gets available options, like all the kinds of nodes that would help some pods in the cluster, and it makes a decision. In 1.7, we have a new pricing-based strategy coming, which sort of tries to optimize dollar cost. But we actually have other strategies as well, like least waste, so just whichever option will have the least unused resources, and so on and so forth. I think we have about 5 different strategies, and most of them are about 25, maybe 40 lines of code. Any other questions? Okay, thank you then.